right, so quick show of hands. Has anyone in the room heard of NatureServe before? It's okay. We're not a super well-known organization. So I'm hoping by the end of this talk you'll know all about us and you'll be thrilled to know that something like NatureServe exists. So what is NatureServe? It's a nonprofit. It's an international nonprofit organization, and the green map that you see represents the footprint of our network of partners. So NatureServe was founded actually by the Nature Conservancy in the 1970s because their mission was to protect land, and they needed more information to know which land should we protect. And there really wasn't a biodiversity information inventory that was comprehensive in the US, let alone the whole hemisphere. And many species rely on migrating, and they travel very long distances. So if you want to conserve a species, you have to worry about where it needs to persist throughout its life history, not just perhaps where you're seeing it at one point in time during one season. So we have over 80 network partners, including here in Pennsylvania. The Pennsylvania Natural Heritage Program is our partner here. And we have about 75 staff who work for NatureServe with me. Our headquarters is in Arlington, Virginia. So I came up on the train last night, nice easy ride. And what we do is we focus on, as I mentioned, biodiversity data. So some of the statistics you can see on this infographic, we track over 70,000 species, plants and animals, and over 1,600 ecosystems. And we, combined with our network partners, respond to more than 6 million information requests a year. And I'll get into a little more information about who is asking questions of this data and what kind of questions they're asking. So how does NatureServe work? So we have, I'm privileged to work in my organization alongside trained biologists, zoologists, botanists, ecologists, together with the information technologists like myself. And they get out literally in the field, and they look for rare species, which can be hard to find because they're rare, and they can be hard to identify. So they're well-trained professional biologists in their field. And together, we're collecting this information, knowing where to go, and getting it into map form. I'm going to show a lot of maps today. The data we collect is very spatial because we're looking at where the species occurred and how it's doing. And we aggregate this data in our central database at NatureServe so that we can transform it and provide all kinds of meaningful information products to solve conservation challenges. The process that we do at NatureServe includes not just aggregation, but harmonizing the data and synthesizing it and doing quality control. So it's really reliable and decision ready. So the kinds of questions these data are designed to answer, we really focus on basics of what it is, where it is, how is it doing, and then with that foundation, helping people to decide what actions can you take to help for those more at-risk species. We also provide a lot of expert consultation services, working with organizations and clients that need our guidance to know how they can take action to be better stewards of the environment. So these are a few examples of the types of clients we work with. And while we have a variety and a diversity of clients we support, we could categorize them into these 4 buckets. We involve with conservation professionals like land management agencies, like Julie there from the Fish and Wildlife Service, with compliance professionals who are in the regulatory business. So we work with EPA, U.S. Fish and Wildlife Service, and others who are safeguarding and ensuring that our environmental protection laws are being carried out. We work with industry who are on the other side of that compliance coin, who are trying to make sure that their practices are not harmfully impacting species. So like the Hancock Forestry group shown here. Sustainability professionals, including corporations or foundations, who are trying to ensure that their practices are sustainable. And then academic researchers, including citizen scientists. So while we have professional biologists out in the field, increasingly there's a huge volume of biodiversity observation data that's happening because of the evolution of the smartphone. People have a sensor in their pocket, and they can take a photo, and they can submit it. And that data, while not always expertly identified, can provide, at a volume scale, more quick response information about what's happening where than all the professional biologists out there can do. really rapidly advancing change in our field that we're trying to adapt our data systems to accommodate. So what can we do with this data? Well, when you roll up all the information about all the species that exist and how they're doing, you can see information like this chart. So this is a chart showing the proportion of U.S. species that are at risk. So the green part of the pie there is not shown. We're taking all the things that are more in the at-risk section of the pie, and then we're showing you how many of those are at risk. And you can see, if you go from the bottom of the chart to the top, what type of species are most at risk proportionally is those ones that rely on freshwater. You can see freshwater mussels, crayfish, amphibians, freshwater fishes. So by and large, the species that get a lot of attention and dollars, mammals, birds, very charismatic, wonderful, but relatively speaking, they're more secure than some of the other plants and animals. So if you kind of drill in on a more detailed spatial scale, the kind of data we collect, the basic unit is a term that we call an element occurrence. So an element could be a plant or an animal or a natural community. It's an element of biodiversity. And we map these in a very detailed way. We use GIS all the time. Do many of you use GIS? Any of you? Some of you? Few hands? Geographic Information System. Think of Google Maps. You probably have a phone that takes you where you want to go and you don't even think about it anymore, but that's GIS. And we rely on that software all the time, and all of the data we collect has a location, either a point, an XY coordinate, or a polygon, a collection of vertices, like you see in this map. So these pink and purple areas are both current and historic occurrences of a species in an area. And we take this information and aggregate it over time. And we look at the trends of, how is the species doing? And if it's looking like it's declining, we might change the status of that species to put it out on a watch list for folks to keep an eye out for its decline and to take management action. And at some point, it might get federally listed as protected, where it can be, there can be more policy enforcement on that protection. So in this map, the green areas are showing counties where the species has been documented as occurring, and the pink and purple areas are areas where our network has been on the ground and observed it. And this happens to be a map for Mead's milkweed, which is a threatened plant that historically occurred throughout the tallgrass prairies in the Midwest. And here's what you can do at a larger scale. So taking all those element occurrences for all those many thousands of species and sort of zooming out at the North America-wide scale, we've got over 1 million map locations of at-risk species, and a very high precision, detailed map that can guide conservation actions or avoidance measures if you're trying to know where you could operate without harming those species. And here's an example of an aggregated or a modeled map of the vegetation types in the country. So we work together with partners. This is the United States National Vegetation Classification, and we've worked with federal partners to develop this classification. It's an internationally standardized classification for terrestrial ecosystems and vegetation types. This map is shown at a 30 meter by 30 meter raster scale. So you can see patterns across the landscape of these different types. The legend is quite large. There are over 800 specific classifications, so I didn't dare try to even show that legend on this map. But we have this product available online, and you can zoom in and you can click on a given pixel and you can read what that specific classification is. And these kind of maps guide land management decisions at both a very broad scale and a fine scale. And you can see they model things that are, sort of very dynamic ecological processes, like, like things that are subject to fire and those kind of changes or flooding. And so we're operating at the sort of hemisphere-wide scale, but we also feed information up at a global scale. So that last map showed you 30-meter resolution vegetation types, and we have very good precision. We're lucky in the U.S. We have very high precision base data on which we can create a map at that scale. But globally, if you want a consistent map across the whole world, the resolution of consistent data layers to make that map is a little coarser. So this is a map at 250 meter by 250 meter cell size. But it's a similar type of map. It's showing you the ecological land units for the whole world. There are about 3,600 unique combinations shown in this map. This is a map that we worked with partners at Esri, which is a world-leading GIS software company. And all of the maps I'm showing today we built using that software. And the inputs to making this map included things like the bioclimate, the landform, lithology, and land cover. So these are sort of the basic building blocks of what make these different ecosystem types distinct. Sort of combination of what's going on under the ground, and in the climate, and on the soil. And then you can do the similar kind of thing in the marine world. So I'm going to click on this video while I talk, just because it's nice to look at something moving once in a while. So these are ecological marine units. And this is, in the marine world, when you're mapping, you're dealing with another dimension. So we're looking at this three-dimensional mapped ocean ecosystem classification, which was developed through statistical clustering. So this is an aggregation and a computation that Esri's server cloud created. And it took 52 million points and global measurements of 6 different variables over a 50-year period in the ocean column. And that data was combined and extracted at a quarter-by-quarter degree, which is about 27 kilometers squared at the equator. And it looked at different depths, and it analyzed, and it came up with what are the sort of nugget of combinations here that represent unique types. And this becomes a standardized map of the ocean, which has never existed before in this detail, and can inform biodiversity planning, can inform economic decisions, social decisions, marine spatial planning of how we use the ocean. So now I'm going to go into a few examples of how NatureServe specifically is applying this data to inform decisions. And if anyone has a question at this point, if there was sort of fundamental questions. Okay. So, the biodiversity data and tools that we've developed with our network partners and can be applied to a variety of challenges. And the examples I'm going to show today include species distribution modeling. So I showed you a number of maps that have pink dots of where we've seen a species occur. But that often doesn't tell the whole story. That really can represent a bias of where we happen to have been and looked for it. So there's a lot of places we haven't been able to survey. So we can kind of fill in the gray areas with a distribution model. And I'm also going to show you a few examples of visualization and decision support tools that we've delivered to help all kinds of conservation users. So for the species distribution modeling, the challenge we face, as I just mentioned, is the map on the left is sort of a point map. It's a simplistic representation of just where we happen to have known a species to occur. So the problems with that map on the left is it's under-predicting the occupied area. And it's over-predicting what's unoccupied, the opposite of that. And again, the accuracy can be biased based on sampling intensity and effort. It's amazing how many biological observations you find right near the highway and close to the trail, places that are easier to access and less infested with poison ivy. It's true, it's in the data, it's biased that way. The other map on the right, however, has different but similar problems. It's over-predicting occupied. It's sort of coarsening everything up and saying, well, we know it occurs in this county, and it might be a bunch of places in this county. It may have been only one little fraction of the corner of the county. So it's definitely biasing it in the other direction. these are both not accurate tools with which to make decisions about how to protect the species or how to avoid harming the species. So our approach, and this has been evolving rapidly with the evolution of the computing capabilities that we have, statistical processing and spatial mapping. But we take all of those known points of occurrence, which were represented on this map as green points, and then we also figure out what's going on in those places. What are the commonalities of these, what we call predictor layers, of what's going on with the climate, with the soil, with other, the elevation, the slope. So what are the commonalities of what makes this species thrive in this location? And you can extrapolate and build a map of all the places where those conditions occur. And in the modeling process, we have taken these predictor inputs and combined them with the species occurrence inputs. And we generally use a stats program like R. There are also some custom algorithms that use machine learning and run multiple cycles. There's one called maximum entropy that we use a lot for species distribution modeling. And we get this final model, and then ideally this becomes sort of a cycle, an iterative process, where the improved models can direct us out to do more field work, and we can do accuracy assessment of where the model said something was, and where it wasn't. We can add more positive occurrences to reinforce and train the model, more negative occurrences, and we can get a very improved process. So here's a little more detail of building the model, and seeing those predictor layers of elevation, climate, soil, and land cover that can be overlaid with the species occurrence points. And you can get this suitability surface where the yellow areas have the lowest suitability for this species, and the purple areas have the highest suitability. And then you can take that and you can set a threshold. So you can kind of turn that surface into a binary map of where it's suitable and not. And where you set that threshold can depend on the kind of question you're trying to answer. So you might be more conservative in a regulatory scenario where you want to avoid harm. You don't want to risk that you cut it off too rigidly. But if you're in another scenario, you want to be less conservative, you want to go find a species, you might open up that range a little bit. And here's a practical example of how we did this in the real world, working with companies who are doing pesticide consultation under the Endangered Species Act. So the map you see on the left, the orangey big blob area, is a very coarse map of where that species occurs, according to the Fish and Wildlife Service tool that is used for guidance on whether there might be a conflict in a place. The dark green areas are orchards where one might apply pesticides. The bright green areas are where our network program had observed this species, which is the Carner blue butterfly, which has federal status. It's listed as endangered. The map on the right, you can see, really narrows in those areas of conflict much more tightly than that big orange polygon into a high to low suitability surface. And then we can take that threshold and say, this purple suitable area is really where you have to be worried about. So then when you overlay those orchards with that, you realize the areas of potential conflict for this pesticide application are much finer than the coarser map would have indicated. So switching gears, models and maps, all these data are great, but can we get them into more people's hands and have them be acted upon than, just in the file drawer on someone's personal computer? So one of the challenges we've come at with this is streamlining the environmental review process. So every state has slightly different laws about environmental review and what you're required to do in terms of getting approval. But there's generally some kind of process in place in all states for permitting and getting approval for natural resources and ensuring that your project will be have limited conflict with those natural resources, including endangered species. So in this project, we worked with the Natural Heritage Program in Pennsylvania. We've actually built this tool in 8 states, including Pennsylvania. And the tool I'm showing is called the Pennsylvania Conservation Explorer, and the URL on the bottom is there. You can visit that. It's open to the public. You can view the maps. You can learn about what natural resources there are in the state. So the approach we took to designing this tool is there's a human decision process going on for environmental review. And historically, a project proponent would mail in a map, they'd mail in an application, they'd describe what they want to do on that application form. And then someone on the state side would review all that information and make a decision. So we tried to model that decision process. So we have kind of a way in the GIS software to model a geo process, to sort of model that workflow of taking input layers, what natural resources occur on the landscape, what's the boundary of the project. There's a simple spatial comparison. But there's also a more complicated set of rules that we can build into that geo process to say, okay, are there conflicts between this project type and this resource type? It's not just there's a project, there's a resource, there's all conflict. You know, some projects are compatible with other kinds of resources. So we can really make a more fine-grained rule process in the software. And we can also facilitate that agency review workflow and customize it on a state-by-state basis to really match their needs. And this is an example of that Pennsylvania agency review process that we automated through this tool. And here's an example of what the tool looks like, the front interface. You can zoom in on the map, you can display different layers, and you can submit a project, and you can fill in the project application, and you can describe, you know, pick a project type, and then it kicks off that review process, and in the background, it overlays your project boundary and your project type with the natural resources that are known to occur there, and it generates a summary of results. And it can give very specific recommendations of avoidance measures. And it can really speed up the process. It can go from months to minutes, which is a huge incentive from the state side and from industry side in terms of speeding through that process and focusing the human decision-making process on the fewer subset of cases that require a more sophisticated set of decisions. But the simple cases can be done right away. So a second visualization and decision support tool we built is called Landscope. And the challenge that Landscope was designed to solve was looking at the accelerating sprawl of land development and trying to incentivize and guide land conservation to the most important places. So to do this, we worked with hundreds of partners, and we brought a lot of information together to document where conservation values are on the landscape and to coordinate efforts across the land protection community. We sought the advice of partners like the Land Trust Alliance and worked with understanding how land trusts that are working, you know, with private landowners are trying to make good choices and strategic decisions around which lands are important to protect and give them the tools to help justify the conservation values on lands that could backstop easements and other legal protections that can be put on the land. So the conditions that we were, you know, fighting here is the trend of land conversion. About 2 million acres of open space have been getting converted annually. So that's 6,000 acres a day across the U.S. It's a pretty big scale. And the rate of land development was also outpacing population growth. So it wasn't just keeping pace with how many people we were adding, but people were sort of taking up more space on a per capita basis, maybe second homes, maybe bigger homes. So there was a sense of urgency. And at our nexus, more than 500 imperiled species are found only in some of those fastest growth metro areas. So we were really concerned about some of these species on the edge of this development and how we might help stem that trend. So the approach to building this tool, I mentioned working with many, many partners. The data in here goes well beyond data that NatureServe and our immediate network member partners steward. It includes information on biodiversity, but also other kinds of landscape values that are important to everyone. Recreation, scenic, cultural, historic, working lands, already existing protected lands like parks. So we wanted to knit all this information together to provide a more easy to access picture of what's going on in a place. And to really both inspire as well as inform land conservation efforts. So So we built a visualization platform, GIS heavy throughout our toolkit, as you'll see. This is also built on an online mapping platform. It's called Landscope. Hundreds of map layers. You can search through these different themes, so many in that conservation priorities category. This map is showing in green areas that have been documented by the Nature Conservancy as conservation priorities. And those priority sites were in fact informed by the biodiversity data that the NatureServe network collected with the Nature Conservancy for many years. It also provides, this is a free tool, you can save your own map, you can share maps, you can send that map you built to your friends, your colleagues. They see what you put together in terms of which maps you had turned on, where you were zoomed in, what level, what extent. You can even annotate and mark up the map, draw something on it, and label it. There are state portals too, so there's Landscope Pennsylvania, there's Landscope Maryland, Virginia. So you can kind of really drill in and understand at a state level, what are the important priorities and key partnerships, really trying to almost broker some of those land conservation communities together. And we can also do this at a regional scale. And one of the success stories for Landscope is happening in the Chesapeake Bay watershed. So Chesapeake Bay watershed, it's a little fine to see on this map, but there's a blue outline that shows the entire watershed in that map. We're just east of that. I think we're in the Delaware watershed here on the map. And the Chesapeake does run through Pennsylvania though, and the Susquehanna headwaters flow down into the Chesapeake. New York State, and Maryland, and Virginia, and West Virginia, and DC, all together are operating under an agreement, a watershed-wide agreement that is also been signed by the federal agencies with the goal of protecting a certain amount of land in the Chesapeake and to reduce pollutants in the Chesapeake. And so part of the strategy to implement that goal was to have a watershed-wide, publicly available conservation mapping tool. And the partners decided to work with NatureServe and Landscope because the map already did what they were looking to do, and it already had many of the information layers in the system. So we're thrilled to be working to support the Chesapeake Conservation Partnership. It's a coalition of more than 50 organizations. Those are federal agencies, state agencies, NGOs like NatureServe, working together on this Chesapeake-wide conservation objectives that is about protecting more land and also providing more sites for the public to access natural resources like trails, water, boating access, and the like. And this, the policy driver I mentioned is this watershed-wide agreement that was signed in 2014, and it was motivated by an executive order that came out in 2009. And here's a little more of the information you can get to beyond the map in Landscope Chesapeake. You can drill in and learn more about featured places that have a lot of a coalition of organizations working to protect and preserve the way of life in these places. One example is called the Journey Through Hallowed Ground, and it spans at the south end from Monticello, Thomas Jefferson's home, up to Gettysburg, and there's a scenic byway, Route 15, that runs throughout there. There are Civil War battlefields, there are many rural landscapes, and there's a sort of a branded tourism initiative to really celebrate that rural landscape and the scenic viewsheds. And some of the data layers include those Civil War battlefield sites and the viewsheds from that scenic byway and the Appalachian Trail, which runs through there. And the site includes maps, not just maps, but photos and videos and stories to really bring these special places to life. Okay, one more example. Going all the way up to the global scale now, and looking at how to visualize global biodiversity patterns. And I mentioned earlier, when you're mapping species and ecosystems, there is not always consistently available data at the same scale at the global level. So there's surprisingly hard to find consistent data to really know what is going on and compare across whole regions, whole continents, let alone countries or watersheds or sites. So the dashboard tool that we built is designed to tackle that problem and help you analyze and visualize biodiversity status and trends across the world, communicate progress toward global biodiversity targets. There's something called the Convention on Biological Diversity, which is a global agreement. You've maybe heard of the Paris climate agreements. Well, there's a similar agreement for biodiversity. The United States is one of a few countries who has not signed that agreement. No judgment, but most of the world's countries have. And there are targets, and the signatories, said we want to prevent the loss of biodiversity in these measurable ways. So there's 20 specific targets. They're called Aichi because that's the place where they had the meeting, Aichi biodiversity targets. And, you know, we're trying to figure out how to help the world community measure how we're doing against those targets. Worldwide, billions of dollars are spent on conservation every year. But it's been very hard to know how effective those actions have been. And are they, are they making a difference? Are they abetting the threats to biodiversity? Are they improving the state of biodiversity? So those are kind of the context and the questions we're trying to resolve with this system. So here we're talking about trying to take this disparate data often and look for some way to harmonize it and normalize it and create indicators of meaningful change. So we're looking for verifiable data sources that are going to be repeated and through monitoring and collection more than once, ideally. So we can see a change from point in time A to point in time B. And we gather these data and we do a lot of processing on them to disaggregate them down to different scales where you'd be comparing across countries, across watersheds, or across sites. And we've grouped these indicators. There's a sort of a framework in place for comparing. There's a theory of change for comparing these indicators between pressure, state, benefit, and response. So the idea is that policy responses will reduce pressures, and that pressure, for example, putting a policy in place like creating a protected area, a park, where you're preventing deforestation from happening. Deforestation would be a pressure on biodiversity. So if you lessen that pressure, that deforestation, the theory is then the biodiversity that relies on those forests the state will be improved, or at least less harmed. And that improved biodiversity state provides benefits. For example, by less deforestation, you've got more intact natural filtration for clean water flowing downstream to human populations. So there's a cycle between and among these indicators. So our visualization platform, the dashboard, has currently about 26 of these indicators that are organized under one of these pressure, state, response, benefit categories. We're adding more all the time. This is a fairly new project that we've worked on. We are using another GIS platform here, so these are not just charts and tables, but there's maps, which I'll show you in a second. And most of the data are hosted on our server, but more and more we can dynamically reach out and tap into partners' data sets that are being fed directly over the internet through services. So that's the trend in these kind of data sets where we're getting them right from the source, and when they update them, our tool is updated. We also allow you to view one or more of these indicators with other reference data and click on the results to see those trends, compare across places, and download the data for further analysis. So here's an example showing the dashboard for one of the indicators, which is an ocean health index. So the ocean health index is giving you, kind of a blue to red, red, yellow, green, right? On the blue side, that's saying things are, relatively improving, in fact, in the overall ocean conditions. The red areas, things are overall worsening and quickly. And the chart that I have shown in this screenshot is for Somalia, and you can see the trend is not going in the right direction. Things are getting worse quickly between those points in time. And each of these data indicator maps we have has a lot of metadata in it, so you can learn exactly who provided this data, what their methodology was, what are applicable uses of this data, and then how can you get more information and download it. So that is setting the stage for making, how do we then use this in a real world setting? So here's an example for the MacArthur Foundation, which helped fund the development of this dashboard tool. They invest as a foundation in the environment, and they have chosen 3 regions of global hotspots for biodiversity, one of which is the Mekong Basin. The other 2 are the African Great Lakes and the tropical Andes. So there's a density and an urgency of biodiversity at risk in those 3 global regions. And they have a long time horizon for their investments in decades, and they want to put in place a system to measure are their conservation investments making a difference. So they were motivated to have a dashboard system like this with indicators that could show them are their investments paying off. So a specific example of their investments is meant to stem deforestation in eastern Cambodia, shown here. And we used the tool and worked with MacArthur to perform a counterfactual analysis to look at the effectiveness of conservation efforts by comparing sites where they made investment to those where they did not. And we looked to see if those investment areas were resulting in lower rates of deforestation at the watershed level over a 9-year study period. And we also corrected out for other influences and factors such as population density, protection status, economic land, and mining concessions. And the results show that, in fact, yes, the areas where the MacArthur Foundation targeted their investments did have an effect that was greater than the sites where they did not, even factoring out those other influences. And that led to them having more confidence in continuing their investments in the region. So that is the whirlwind tour of NatureServe and our Biodiversity Data Collection Network. The data we're collecting, and it's snowing outside. Very exciting. And a range of example applications from modeling to decision support tools to visualization. So there are sensor data that are collecting information at those different points in the water column, temperature, salinity, abiotic and biotic, and on the map there's an Esri software company reference. They host that data and they put out a number of information products, including a 3D tool where you can fly through and view the data, and there's a lot of more metadata about all the specific sources there. Those are some examples. It's sort of how you can characterize the differences in the ocean conditions and then classify what's happening at those different depths. Some of it includes the substrate surface too. And part of my answer, maybe I'm not on the science side of NatureServe, I'm on the IT side, so I only know as much as I know on the details of the science, but it has to do with the temperature, salinity, what's going on at the surface floor, and in between, from the top to the bottom, and then characterizing it. Yes?
I've been on your web. We work for land trusts in America, and we do a lot of research on birds in particular. We collect data. What is our do you just want data sent to you that is collected that we collect for other purposes? I've been on your site. It's a little, I'm going to be honest, it's a little intimidating to navigate as a landscape level biologist.
And you're talking about Landscope or NatureServe?
I'm just talking about getting on NatureServe and like figuring it out.
Okay.
You explained a lot of it, but it looks good when you explain it, then when you actually go to do something, it's very
Someone's not there, yeah.
for a common person.
Sure, yeah, because these are a few of our data sets. You come to our front door, natureserve.org, and it's like, who are we, what are we doing, and what do I do about that? And we're trying to get better with that, with our new marketing person. But, to your specific question, what to do with data that you might want to contribute, the way I would direct you is, if you're in Pennsylvania, operating as a land trust, is the Pennsylvania Natural Heritage Program, because those local collection observations I described come to us through each of those 80 local partners. So each state's heritage program, Pennsylvania, New Jersey, Delaware, we have a common database, and they collect the data at the local level of observations of species, and we aggregate it from each of those partners. So we don't directly add to that. It goes through our state so that they're knowing what's going on in their state, and by collecting the information across all the states, we then get a picture of how the species is doing globally and across its whole range. And so we collectively assess the status of that species, being informed on the condition and how it's doing across many places. And we have tools that help us assign that rank in a transparent and consistent way. We have an actual algorithm, like a calculator, that takes a bunch of inputs, like the condition at a given place and what the trends are, and then we give it a score, and that's how we get that it's most imperiled or to most secure. And because I mentioned earlier the explosion of say citizen science, and there's many more observations becoming available every day through a lot of mechanisms. There are other vehicles for birds in particular. I just have to mention, like eBird. Cornell is very, some of you might have used that app on your phone if you're into birds. So there's large groups like Cornell that are collecting millions of observations on birds. And so that is one place that can also come in and then gets to the heritage program for what they're kind of on the watch list for in Pennsylvania. Because we tend to focus on the more at-risk species and not the more common ones. Although things can change quickly, and things that we think are common today could be at risk later. So we still need to know, how things are doing.
So a lot of that data is automatically coming to you, so we wouldn't have to make any extra effort.
That's right. That's right. Yes.
Do you share any of your data? Is your data public?
We do. So every tool I showed today is public. So Landscope has hundreds of maps. Some of it are NatureServe data, some of it are from partners. But a public layer that we share on Landscope and in other of our tools is looking at which species at risk occur in a given state, in a given county, or in a given watershed. So there are reasons why we don't publicly share the most precise location of a species, because some very rare species are considered sensitive. There's concern that harm could come to the species. Too many people knew about the last occurrences of a very rare species. So we have an agreement with our state partners that we don't publish openly that very fine scale information, but we generalize it to the county and the watershed. And if you're familiar with watershed data, they have these digits, as HUC, hydrologic unit. I forget what the C stands for, but it's at the 8-digit HUC scale, if that means anything to you. There's on the map you can see, but it just gives you more of a natural boundary for where what's going on in the area versus an administrative boundary like the county. And so that data is available, and we have a tool called NatureServe Explorer, and it's also freely available. So you can search by species name, or by location, or by status, or all three. So you can basically say, I want to know every bird that occurs in Pennsylvania, or you could filter that a little bit more and say, I want to know all the birds that are at risk in Pennsylvania, or all the birds that have actually been extirpated, that once were in Pennsylvania but are no longer. So you can kind of combine those queries on our database search and get a list of them and read all about the information we have about the whole life history of the species, images of it, distribution maps, kind of from the state scale for a county or a watershed scale. One thing that would be interesting is if we could open that data out at a more volume level. We talked over lunch about that with some of the faculty. Open this data set and get more university students, researchers, and analyzing it and taking it to making other conclusions of it. That's something I think as a network we need to discuss and decide ways in which we can turn out more of an open data portal. But there are ways to get to it now by going to our website and downloading it or sending us an information request.
Around students being interested in this field, kinds of background and stuff.
Yes. So GIS came up a lot in my discussion, and it's an important fundamental tool that we use in mapping information and analyzing spatial information. So pretty much everyone that comes into NatureServe, whether they're on the science side of the organization, so I don't know if I said this, there's about 75 staff that work for NatureServe. More than half of the staff are biologists, zoology, botany, ecology, but they've been involved with using GIS in doing their research. So conservation GIS and GIS, there's certificates you can get in GIS, there's online or through traditional curricula. On the information technology side of our business, also an important tool because every piece of data we manage has a spatial component. It's tied to a place. And we do a lot with statistics and analyzing the data, looking at trends and looking at confidences and those probability models I showed, doing distributions and kind of tightening down to those confidence ranges. So for the conservation side, there's conservation biology, there's taxonomy, and knowing how we classify species and natural systems, and then spatial, the spatial tools, GIS, spatial analysis,